my session title is a little ambiguous. Hopefully, you all saw the keynote this morning and have a little bit of idea about what the session is now going to be about, because there were a lot of stuff that we couldn't talk about. There were a lot of things that we couldn't put in abstracts and things of that nature. And so, we went with the evolution, because really that is kind of where we're going, where we're building, and where we're really seeing Terraform Cloud going in terms of its usage within just the regular Terraform workflows. So I had a little bit of an introduction, so I'm going to skip over this because we have 45 minutes and a lot of stuff to cover. So primarily, we're going to be going over those 3 stages that Armand walked us through this morning as part of the keynote, going over what the workflow is, getting into standardization, getting into scale, and then plenty of time for demos. All right, so let's dive in. So the first phase of the journey of what we kind of call the automation or the infrastructure automation journey is really just adopting infrastructure as code. Now, for the most part, I'm going to assume that many of you in this room, because not only beyond the session title itself, but because you're here at this event, probably have some notion of what infrastructure as code is and what it does. However, when we look at the workflow itself, this kind of comes down to several different angles of how you can run your Terraform workflows. The primary one is the one that everybody gets started with. It's the command line workflow. This is the place where you run your Terraform plans and your Terraform applies, and then you get your output, and generally a lot of things end up locally. Then we get into the version control workflow. This is kind of being touted as GitOps, if you will. This is when we are integrating Terraform into our version control, whether that be GitHub, GitLab, Bitbucket, what have you, so that we kind of have a plan of action. Whenever something happens to our repository, somebody makes a commit, somebody makes a pull request, something happens, Terraform can then go ahead and do something based on that action. Then we dive into the just, whatever you need it to do, it can do, API-driven workflow. If you want to integrate this into a CI/CD pipeline, totally okay. If you want to, build in customizations and integrations into, say things like Vault, as we have on our example here, pulling out some of those dynamic credentials, you can do that. You can do anything that you want to when it comes to the API workflow. So a little bit of show of hands here. When it comes down to the workflows, what's the workflow that you all prefer? Let's start with the command line. Anybody prefer the command line? All right, you don't have to be shy. We're after lunch. You all have been warmed up by now. I don't see anybody sleeping. Okay, how about the VCS workflow? Excellent, excellent. And the API-driven workflow? Very nice. Very, very nice. All right, so let's get into a little bit of enhancements when it comes to the command line workflow in terms of how maybe you can build on top of the command line workflow to get into a VCS-driven workflow. So what we did as part of Terraform 1.1, because we kind of haven't all talked as a group since Terraform 1.1 was released, we added what's known as the Terraform Cloud integration. And so this is a block, a code block that lives inside the Terraform block, and it basically helps you to interact with Terraform Cloud from the command line in a very native experience. This is extremely helpful in terms of those situations when you have multiple local workspaces. Those workspaces all of a sudden now appear on Terraform Cloud. If you need to use command line variables, you can do that with the cloud integration. You can do all those things through that with Terraform Cloud. Then we also have a really cool new addition that's really been gaining speed and steam, and that's called the Cloud Development Kit for Terraform. This is something that we worked with AWS on to kind of build the fundamentals, and then rolled it into our own Terraform offering so that you can use some of those maybe programming languages that you're already using to then create, manage, and provision your resources in things like TypeScript, Python, Java, C#, and Go. But some of the really cool things that you can do with this, especially in the later versions that we've recently released, is you have the capability of reaching into the entire Terraform registry so that you can access any of the providers that are out there. If a CDK iteration isn't already available for you, CDKTF, that project, will build it for you on your behalf. So all of a sudden, you have dynamic access to everything that's in the providers, and you have it at the time that you need it. You also have the capability of turning in your programming language-based code into HCL. This is extremely helpful for the developer side folks who maybe want to create resources in their programming language, but then they maybe need to hand it off to like an SRE or a DevOps style team. That's possible with the CDKTF project, and also vice versa. So then building on top of that, now we're getting a little bit away from the workflow, and now we're getting into the standardized phase. This is how we kind of get to the point of being almost self-service with regards to the Terraform workflows and how people are using and consuming resources within your environments. So one of the things that Armand talked to this morning, I see my slides have been a little modified in terms of where my pointers are here. However, one of the things that we pointed out this morning is a new addition in terms of Terraform 1.2 in the use case of pre and post conditions. And I'm going to have a demo on this to kind of show you exactly how this works out. But really, this is kind of like variable validation being brought to your resources, except you can also use this against data sources. You can use this against your outputs. Pretty much any aspect of your Terraform configuration, whether it's in a module or outside of a module, you can apply these. Now, the one big thing that at least spoke to me in terms of adding these pre and post conditions into my own Terraform configurations is the ability to reference and pick out things that Terraform doesn't actually know about until it's been already created. We'll see that in the demo here later, but very powerful from that aspect, and definitely helps just standardize the way that modules specifically can be used and achieve better success rate with those modules. Then we get into a feature that's known as variable sets. This is a really cool feature that gives you the capability of defining sets of variables and then applying them to one or many workspaces within an organization. Credentials is probably the first thing that comes to mind as something that you reuse in different workspaces repeatedly. You can now instead assign a variable set, update the variable set, and you don't need to mess or really get in depth with any of the workspaces that are out there and exist. A couple other areas that are out there, if you have production environments, those might have their own sets of variables. If you're in a development environment, you might have different sets of variables, and you can kind of standardize on what those are and how they interact with those workspaces. Then we get into another cool feature that we kind of talked about this morning in the keynote, and this is how we bring in third-party tools that you already may be using within your environments now and have them interact with the Terraform workflow itself. So those tools always have the latest and greatest information available about your infrastructure and about those resources, and have them in the middle of the actual plan and apply process. Now, we partnered with many different integrations here in terms of focus areas of security, cost control, and regulatory compliance. A lot of these companies are probably tools that you already have in your environment now, and we're continuing to build on this. Some of the key ones here have been Bridgecrew and Sneak. One of the latest ones was Strya with their OPA service, their DAS service that we just integrated as of, I believe, Wednesday of last week. Then Infracost has been part of our run-tasked public beta process. They've been there from the start. And then we see, again, folks like Bridgecrew and Kion when it comes to regulatory compliance. So all of these can pair into the Terraform process, into that workflow, so that you can run checks, you can validate things. It has a very Sentinel-like experience. And again, I'll show you a little bit more about that here shortly. Then we get into the registry. Now, hopefully you all are very familiar with the registry, and maybe you've seen some of the improvements that we've been making over these past couple, really, months. We've been performing updates to not only the performance, but also being able to provide additional metrics. So for those of you who are contributing providers into the registry, first and foremost, thank you. Second, hopefully a lot of the metrics that you can pull and some of the observability that's out there is well received. And a lot of the things that go on within the registry, we're now over 2,000 different providers. I think as of this morning, we're even above 2,200. And I think we just missed the mark on 10,000 modules. I may have been a little overzealous in how many modules we're going to be out there. However, the thing that's seen a lot of improvement because of the public registry improvements is the private registry. So we've done a lot of work to the private registry that's available in Terraform Cloud as well. So now you have the ability to integrate providers. You can even pull providers from the public registry into your private registry. You can do the same thing with public modules as well. You know, we're getting to the point where your private registry is now the one-stop shop, if you will, for resources and reusable configurations within your environment. So no longer do practitioners or developers have to go out to the public registry and see, holy moly, there's like 1,000 different ways to create an EC2 instance. You can now just say, no, this is the resource that we use, this is what we've standardized on, and it's right there in the private registry. So then we build out a little bit further into the third phase. Third phase is probably where I'm excited the most about, because scale was always this performance-driven problem that I was always attracted to. It's a very complex thing to solve. It's a very it's a very hard issue to work around as well. But here you continuously optimizing, continuously building on the code that you have, continuously upgrading your configurations and things of that nature. And so what we've done with that, and we're taking a little bit of a step back to Terraform 1.1. This is when we introduced the moved block. And what this does is it's kind of a enhancement of Terraform move. If you've ever used that from the command line, just Terraform MV. And this allows you to codify those moves as part of your configuration files and store them in your repository itself. This is extremely helpful when it comes to refactoring. Because refactoring, when you're moving resources either from your just general configuration file into a module, or perhaps between different modules. This is kind of that story of the optimization when it comes down to it. But the move block lives in your version control system, and basically it tells Terraform what to move, so it can kind of eye things up. We've got a demo on that as well. Then, as far as optimizations, we always hope that people are on the latest and greatest versions of Terraform. However, we also know that that can sometimes be an issue. It's sometimes hard to upgrade. So what we've done as part of Terraform Cloud is added additional actions that you can perform through the Terraform UI. And basically, you can do speculative plans, but you have the capability of specifying which Terraform version you would like it to run against. So if you're on, say, maybe 0.15 and you want to know what it looks like, can we upgrade to Terraform 1.2? Can we upgrade to the latest and greatest version? You can run this plan in Terraform Cloud, and it's going to go ahead and check that plan and tell you, hey, we've reached success, or maybe you see some errors that you need to go back and maybe think about before you process and get into the upgrade phase. Then the big moment of our morning keynote today was really around drift detection. This is another one of those cases where Terraform is really great at provisioning, it's really great at mid-state management, and it's really great at destroying and cleaning up those resources. But what happens in between all of that? What happens with the life cycle of all the things that you provisioned, all those resources, all those different things within your environment? You kind of want to know if something's changed, right? So what we've done with drift detection is provided that capability. So literally, you can just go in through the workspace control, turn on drift detection, and it's going to periodically go through and check and say, hey, what's the state of your version? Does it match with what's been provisioned in our environment? And give you a nice little alert. So you can either just do the UI-based alerts, or you can tie that into the notification system using webhooks, email, Slack, and Teams. Excellent. All right, so what we have here is a fairly basic setup for an AWS. It's a basic web server, essentially. Stands up all the supporting systems to stand up a publicly available EC2 instance, and then it just creates a very basic Apache index.html file. So I've already ran the first part of it because that's not very exciting, and it kind of takes, this took about 5 minutes to run through. So if we click on that, we're going to see that in this case, it's just we're just pulling in the HashiCorp product or tool in this case, since it's Packer, and it's going to give us our public IP address from the AWS instance, and it all injected that into the HTML code that we're seeing here. But now we kind of want to build on this. So we have our configuration. You know, it's kind of complex. If we go down to the bottom, I think there's like 191 lines of code. Like, this is not something that somebody starting from the beginning is going to be able to produce and really find success with very quickly. However, the first thing, since I want to share this with a team, is I want to introduce our cloud block. So I'm going to switch branches here, and we can see that we have a new block that's right here. It's just our cloud block. I can specify the organization that it needs to talk to, and I can either give it a workspace name, or I can give it some dynamic tags. And the important part about the tags is that lets me create workspaces locally and push those up to Terraform Cloud. So let me clear out my screen here, and we're going to do a initialization. So we're going to set up the connection to Terraform Cloud. And what did I do wrong? It's not a strong sign if we're already failing on the first step here. Why does it think it still thinks that I have an old workspace that's out there, so I'm going to do something very bad, and I'm just going to trash this. This is definitely a do as I say, not as I do moment. All right, let's try this again. Hey, there we go. Okay, so now it's asking me, it says, hey, we see some resources that are local. Do you want to move this up to Terraform Cloud? Yes, I say we do. And then it asks us for a workspace name. So we're going to give it a HashiCorp session demo, something that is unique and that I didn't just destroy. So we've got our initialization successful there. If we come out to here, we should see, there we go, our HashiCorp session demo, updated just a few seconds ago. It has no idea about our underlying, our configurations, but it does have those resources. So, you know, it's pulled in our resources, pulled in our outputs. So we're good to go from that aspect. Switching back to our code here. Let's see, I'll probably, since we might run a little tight on time, so I'm not going to run another plan. So let's clear that out and move on to our next phase, which is kind of the optimization phase, where we're going to introduce now some modules to our configuration. So we're going to take our, there we go. So we're going to take our 190-some lines of code, and we're going to condense them down into 2 different modules. So first we have our web server AWS module. That's just this is how we deploy an EC2 instance that matches up to a web server that is service specific. And then we have our web server config. This is the less service specific configuration and allows it to take anything that's sent based, and then it applies the configuration that we need to meet our criteria here. Now, however, the issue is that if we go ahead and do I'm actually going to have to do another Terraform initialization because we have modules. So Terraform needs to know about those modules. But if we go ahead and do a Terraform plan now, those of you who have done this before know it's about to freak out. It's about to say that we see some stuff that are out there. We're going to need to replace all of those things. So we're going to need to take down your environment, and we're going to need to re-provision your entire environment. That's not what we want to do. That's, if I was in a production environment, or this was, say, an e-commerce type site, I wouldn't want to take that type of outage. So that is not what we're going to do. We can see that it's recreating some of the things that I do on the back end to do some shuffle action, so that I never quite know what tool or product I'm going to see on that web page. Oh, come on. Well, yeah, so it's going to tell us that we need to destroy those things and we need to recreate those things. Oh, there we go. There's our plan status right there. And that's not what we want to do. So what we're going to do is introduce a move.tf file. And those of you who are familiar with Terraform, you can put that wherever you want to. It can be its own file. It can be within the main configuration. Doesn't matter. But basically, all we have to do is match up the resources that exist and tell it what we want them to be in the future with our module now. So like our Elastic IP address is going to be moved into our source module, as it were. And then we can do things, same thing for our EC2 instance, moving that into the module. And we can even do things such as, my crazy stuff like our random integer. We can even move the state of that into our module as well as our random shuffle data. So at this point, we're able to go ahead and then let's skip the plan and dive right into, We're going to run right into our apply phase. So in theory, what it's going to do is it's going to look through, it's going to evaluate that move configuration, and it's going to start matching those things up so that it can, basically update the state file. And then once it gets beyond the plan, because it should find nothing that it actually needs to do as part of the plan, but it's still going to need to hit the apply to actually match those things up within our state file. There we go. And then it should jump to the next phase where it actually makes those moves exist. Come on. So this is a really nice way to kind of build out, as your kind of infrastructure evolves, this allows you to, take advantage of not having to destroy everything and recreate things just because you moved into a module. Oh, there we go. Yes, we do want to perform those actions. So then, this gives a really great user experience from that area, as well as you start evolving the way that you provision infrastructure as code, the way that you manage your resources to get to that end result. So this should take fairly quickly because it's not actually doing any actions, as we can see by our plan output there. There we go. All right, so everything is changed there. So if we clear this out, we can do a Terraform state list. And this is going to list out all of those resources. So we can see all of those resources have now been moved over to our module. I forgot to show this earlier. We can also do a Terraform workspace list. And we will see that it created that workspace here locally so that we can take advantage of that. All right, so now we want to, so what we're doing right now is that we are using Terraform 1.1 here on our local system, but we want to upgrade to version 1.2. So we want to take advantage of those pre and post conditions that were just released. However, what we want to do is test it out, see what it looks like. So let's see, okay, yep, got all that in there. So now we can do a start a new run. And as part of this, we've also done not just the capability to do the speculative plan, but we've also added quite a few new additions that are out here, including a refresh state, which is basically the action after what drift has been detected. We can do our plan only, or we can even do an empty apply for some of those older configurations. So here we see that it's using Terraform 1.1.9, and we can upgrade and say, what would this look like if we use 1.2.3? So here it's going to kick off this plan, and we should see fairly quickly, what the action may be or may not be. But the key point here is just being able to check out the difference in between those versions without actually impacting your environment is extremely powerful, especially when you're on the admin side and you have to worry about things like those. So we see with no changes, infrastructure matches the configuration, So we should be all set and ready to roll from that aspect. Even though it's still going, but we're going to move on. So now we're going to move on to the next part of our demo here, and we're going to introduce Terraform 1.2 and our pre and post conditions. However, I'm going to go ahead and clean up my environment here for just 1 second. We're going to move over our into our area there. What did I do? I'm missing an A? Oh. Oh, yes. Spelling is hard, let me tell you. Everything's against me. I appreciate the enthusiasm. What is happening? All right. Oh, wow, it doesn't find anything in that folder. What is happening? Yeah, when in doubt, we'll just go back to trusty old brew and let that rip. All right, so let's go through and show you what updates have been made to our modules here. So what we've done here is, we moved all of those things into our module. However, some of the new capabilities that are here as Terraform re-downloads in the background, we can add these lifecycle blocks. And these are kind of what I was describing earlier as to, some testing or being able just to validate the infrastructure and resources that are being used within your environment. So in this case, we are testing as a precondition, meaning that we're going to run this test or run this validation before we actually generate the resource to verify that our VPC has DNS host names enabled. Now, this is kind of a cheat because I've actually defined it in our AWS VPC, but that kind of helps to show that it's going to error out fairly quickly. Are we done? We are done. Okay. Cool. All right, so now we're going to do another Terraform init. And run our Terraform apply. Or actually, let's just do a plan, because that's all it really needs. So it's going to go out, it's going to run through our configuration, and then it's going to hit that pre-condition. Oh. What do you mean, blocks are not? Oh, I know what I'm doing. Yep. It's still referencing this out here. Update that real quick. There we go. Run that one more time. So that's another one capability of when you're running things locally. It actually, when it's running a remote execution, it will still use whatever's been configured on your remote side. So in that case, it was still seeing that we were using Terraform 1.1 remotely. So now, as soon as this is done, we should, oh, there we go. Yay. All right, so we have our resource precondition. We see our pretty nice little error message that's right there. It's going to give us what line our condition was defined. It's going to tell us what the attribute that we were checking, what that is, because that's what we just tested against. And then it's going to give us that custom error message that we were able to define as part of that lifecycle block. And now the really important thing when it comes down to it is it stopped our Terraform plan. Like, it stops the operation cold. And that is really just helpful because then you don't have to wait on something to continue further in a misconfigured state. More specifically, if we jump into, say, maybe a different configuration or a different workspace. So let me do a clear there, Terraform, workspace, new. All right, there we go. And let's do a Terraform init, because it's going to have to recreate that and do our Terraform apply. And another say, do as I say, not as I do. We're going to hit it with an auto approve, just so that it can send it right through. Actually, nope, that's going to fail because I didn't correct our precondition. But that's another use case of when it errors out early, I don't have to wait for the entire thing to run through. Hopefully. Yeah, there we go. All right. So now we're just going to go out here and do, it's using our new workspace. So if we swipe over there, we should see our HashiConf demo new workspace that I just created. It's out there. It's currently running through the plan operation. However, now what it's going to do is it's going out there and it's looking at our AWS instance. So in this case, it's the exact demo that or the code that you saw this morning as part of the keynote. And it's checking for that volume size of our root device. Because we've basically clarified that as part of this configuration, we're importing whatever the default block size or root disk size is from the AMI that we're using. But we're specifying out that you're going to find the greatest success when you're using the disk size of 8 gigabytes or above 8 gigabytes. So still thinking. All right, I'm going to leave that running, but since we're starting to run out of time, we're going to switch back to our Terraform Cloud overview. So what we're going to do now is we're going to add some guardrails to the workflows that we're running. So what we can do is, first and foremost, we can enable some policy sets through Sentinel. Sentinel can do some really powerful things. It can check your configuration, it can check your plan output, it can check your apply, it can even check through and verify your state files. So in this case, we are going to attach this to, actually we'll not do that on all. There we go, and so we're going to add our workspace there. And run back down. And now what we can do within our settings is we can go to a new little pocket that's here called Run Tasks. So as part of Run Tasks, we have a couple that have already been pre-configured. So I've gone ahead and set up InfraCost, and I've set up Sneak. So both of these, you can add them directly through. And it'll give you enforcement levels, meaning that you can either be advisory level or it can be mandatory level, so that if something were detected, it can stop the run. If you've ever run Sentinel, it's very much like that. Boom, both of those. Now at this point, we're going to create a new run. I'm just going to do a plan only because plan only also makes use of our run tasks. However, while that's thinking, we hit another error. Now we're VPC limit exceeded. That's what I get for using our internal environment. Here, but what we were testing against here, just to show you, it's our VPC subnet security group, route table instance is going to be the very top because of course. Yep, there we go. So what we were testing against there was our root block device. And again, because I didn't specify any of that, we don't actually know any of that information until after it's been created. So all of these things are known after apply. So Sentinel wouldn't be able to pick this up until it's been created and provisioned and made available. So this is a cool kind of capability to add that in directly even beforehand. So now, going back to our other workspace, we have our plan has finished, our tasks have all passed, so we can see things like our sneak capabilities. We see that there were no issues found, and if we click on the Details tab, it'll take us out to our sneak console, where we can see things like we have a non-encrypted root block device. It'll even give you some suggestions on how to fix it. And it even gives you like different severities and things of that nature. If you're a Snake user, you probably know all of these things. But these are some core capabilities that run tasks can introduce into the Terraform workflow. And then the same thing for InfraCost. InfraCost is going to tell us that right now it was only a plan. We didn't create anything, but our monthly cost is going to be about $10.73. And it gives us details, the capability to click on that, take us out, and view a little more granular capabilities into that. All right, so as we're almost out of time, let's dive into what we talked about this morning as part of the keynote, and that's drift detection. So what we have here is another Terraform Cloud environment, because I wasn't, you saw how my demos went already. Wasn't quite ready to maybe turn that on within my own environment and blow stuff up. But what we have here is another Terraform Cloud organization where we have a bunch of different workspaces that have been created, and each one of them are in various states of drift. So what we can do is click on some of these and say, let's go into drift detection 1, if we were. So we can see a couple things that are now available on the screen. First and foremost, in the top right side, we can see our resource count, what Terraform version we're using, but more importantly, what status our drift is in. In this case, our workspace is in a drift state. We can also see that next to our tab that's down here, we have a little icon that's available there. And then it's going to give us information about what's happening with regard to our workspace and what status our drift is in. So what we have here is a fairly basic deployment or resource that's been deployed. This is an Azure managed disk. It was configured to have 1 gigabyte worth of disk space. However, what Terraform is finding in Azure is that it actually has 2 gigs. So it's told us we've drifted, and the last assessment was about 9 hours ago, because as of right now, as part of the public beta, those checks are happening once about every 24 hours. And then from that point, we have the capability to, we have a couple pointers so that we can address, is this right? Is your infrastructure in a right or good state? Well then, run a refresh only apply, so then that'll upgrade your state file. Or if your infrastructure is in a bad state, you can tell it, go ahead, rerun your plan and apply and fix that. If we go over to a little more active workspace, that's out here, we have a little bit more drift that's going on out here. So like I believe a lot of these are tags, however our SSH security rule has suddenly disappeared. That's sorry, I didn't mention that earlier, but you can see by the little designations on the left and on the left side there. In this case, that security rule has been deleted, versus some of the others that have the squiggly line. That just means that it's been modified and changed. So in this case, what we can do, let's just go ahead and kick off let's do the whole thing. And that might take a second. So one more thing that I want to do to kind of show off because we've done a lot of really cool things in terms of how we manage variables and how we interact with that. So what we're going to do is create a new workspace. We're going to call this out to our version control workflow. We're going to take a look at our GitHub repo where we have a whole bunch of things that are in there. But we want to, let's import this database server AWS. So in this case, we're doing, accepting the defaults, letting it roll through. And now what's going to happen as part of the way the Terraform Cloud operates with those version control integrations and workflows, it's going to go out and actually read in information from the configuration. So now it can actually detect what the variables are within this within that configuration. So we can see that we're using HCP Packer. And as part of HCP Packer, we need a secret, we need bucket name, we need channel name, we need some of those things. So we can actually just enter those in from our screen right here. And it'll import those into our workspace so that we don't actually have to do it manually or do it ourselves. So right there we can see what the gibberish that I typed in is now available as part of the workspace variables. You don't have to go through the process of managing those. We can also see that because this is going to be an AWS environment, variable sets has already been associated with it. So we already have our different environment variables that have been attached to that so that we can authenticate to AWS. So that's a really nice capability that's been added in that just allows you to streamline that entire process. And we're probably going to run out of time to finish this, so let's head on back to our slides. So we have a little bit of a wrap-up. There we go. All right, so to learn some additional things, we have a lot of stuff going on. First and foremost, you probably learned a lot about these things in this morning's keynote. There was a lot of information that was in there, including things about Waypoint and HCP Packer. Which shout out to the HCP Packer folks. They have a session that's going to be later on today where it really builds in how run tasks can integrate with HCP Packer so that you can actually do some validation of those AMIs or instance IDs or images, depending upon which service that you're using, and make sure that Terraform is only using the ones that it's supposed to. Then we also have some, HashiCorp Learn, or the HashiCorp Zone is going to be out there. Each of the different product areas has their own little setting. There's going to be demos, there's whiteboards, there's Ask the Experts, all kinds of access to folks. Anyone from VP of Product Management, VP of Engineering, folks like myself, and even Terraform engineers that we have here and available in the HashiCorp Zone. Some things that you can use when you go home, learn.hashicorp.com. That's going to be a really great resource to have walkthroughs on some of these new capabilities and features. Generally, when we release a feature, we have a learn guide that goes right along with it that kind of helps you walk through the process of being successful with that feature. Terraform.io was recently revamped. However, the documents page is something that I go to almost on a daily basis, and we keep that up to date as well. And then if you want to get started with Terraform Cloud, app.terraform.io, there is a free tier, so there's no cost associated with getting started there. So with that, I believe I'm out of time. So thank you all very much.